This is 9.3, solving multivariable linear systems. We just got done learning how to solve a system of equations. Typically, we did two equations, so two lines, or a parabola in a line, or in an exponential growth and a parabola, whatever. We did typically we did two systems, two equations, and we solved them. Now here we're going to look at three equations, or I might give you four equations, and I want you to solve them. Now, what we're trying to solve, typically when we solve the previous problem, the problems that we solved for an x and a y. Now that's called an ordered pair. That's really what that's called. Because, and you're like, well, why is it called an ordered pair? Well, first of all, it's a pair of numbers, x and y. It's a pair. And it's ordered because x has to be first, and then y has to be second, so it's ordered pair. Well, with three variables, notice we have an x, y, and a z. We have, this is called an ordered triple because it's got to be, it has three variables, and it has to be in that order, x, y, z. Now, normally we would graph this, this x, y point, and on a piece of graph paper, we have our x line, we have our y line. And so how do you graph x, y, z? Well, we live in a three-dimensional world. And if you've never seen it before, so normally here's my x, y graph. I go over 2 and up 3. That's the point 2, 3. But in a three-dimensional world, it actually has a z coordinate, so x, y, and z. So you go over 2, up 3, and then you go up on the z-axis 4. So if you look around in wherever you're sitting at, or watching this, you live in a three-dimensional world. Everything that we see has a length and a width and a height, and that's really what we're doing, is we're graphing in 3 dimensions. Now, we're not really graphing these problems, but I just want to let you visualize, see what we are doing is we're solving for these this system of equations. And we don't have to graph them, but again, we're going to solve it using a process of solving, using substitution and elimination at the same time. Now, I want you to notice this is also called row echelon form. So I'm starting off this first problem with a nice, easy problem just to show you what we're trying to get it into. Now, what is row echelon form? It's a stair-step pattern with 1 as the coefficient. So if you notice, this is a 1, this is a 1, this is a 1. And it's a stair step, so it kind of goes diagonal. So it's a stair step pattern with 1 as the coefficient. Now, as soon as you get it in row echelon form, then you can easily do this thing called back substitution to find the answer. So notice if I start at the very bottom, z equals 2. Well, I know z now. If I back substitute it in, so that means y plus 3 times z will equal 5. Well, y plus 6 equals 5, which means y equals -1. Back substitute it in. Now I know my z and I know my y. Now I just need to solve for x. So take the first equation, x minus 2 times y plus 3 times the z will give you the 9. And so that's x plus 2 plus 6 equals 9. X plus 8 equals 9, which means x equals 1. So my ordered triple is 1 is your x, y is your -1, and then z is 2. And you write it in that way. Okay, you write it in just like an ordered pair. You write the ordered triple, x, y, then z. So now, how do you get it in row echelon form? Because again, the ideal thing is to get this row echelon form, the diagonal, 1 first, 1 first, 1 first. Get it in that, and then back substitution in. So how do you get it in row echelon form? Because most of the equations are not in row echelon form, and we need to get it in row echelon form. Well, we're going to use these things called row operations. And you're saying, what are row operations? Well, you've already been doing row operations when you're solving a system of equations. So here's an example. And so let's look at these. So the first thing is we could switch the placement of the two equations. So what we could do, by the way, let me mention, notice I labeled this equation 1 and equation 2. Because you're going to start having several equations and you need to kind of keep track of them. So I recommend, and so does the book, so does many websites, recommend that you label your equations so that you keep track of them. So like equation 1, equation 2. All right, so what we could do is take equation 1 and equation 2. We could swap them. So I could write x minus y equals 0 first, and then 3x minus 2y equals negative 1. And you might say, well, why am I swapping them? It's the same thing. But remember, to get it in row echelon form, we want 1 to be first. And notice now I have 1 first. So it helps me out to get it in row echelon form. Again, it's not necessary, but it's eventually, if you're trying to get row echelon form, you do need a 1 there. Now, our next thing is that we could multiply the equations or add and subtract the two equations. So you're basically going to start using the elimination process. So let's cross out, we want this, we eventually want this to be a 1 here too. We want that to be a 1, all right, so we can solve for it. So what we're going to do is I'm going to eliminate the x's. And if I wanted to eliminate the x's, I'm going to multiply by negative 3. So I'm going to multiply this whole top equation by negative 3, and it becomes negative 3x plus 3y equals 0. This one does not change. And using elimination, the x's eliminate, and I get 1y equals negative 1, or just y equals negative 1. Now, if this is my third equation, so I'm going to label this third equation, third E, or equation, let me stay consistent, so EQ3. So notice what I have now. If I write equation 2 first, 1x minus y equals 0, remember that's equation 2, and I write y equals negative 1, that's equation 3, I can back substitute this in. So now that I know y equals negative 1, I'm going to substitute it back into this. So x minus a negative 1, which means x plus 1, and then minus 1, x equals negative 1. So my ordered pair, again, it's called an ordered pair because I only have two variables. So I have negative 1 is my x, and then negative 1 is my y. And again, you could graph it to check it, or just simply plug it back in to see if it works, and you plug it back into both equations. All right, so that's, I just wanted, that illustration, like, well, we already knew how to do that problem. Yes, but I wanted to show you row operations, and we're going to try it on this problem right here. All right, so notice I have 3 equations and 3 variables, so I'm going to try to get an ordered triple. So the x, then the y, then the z. I also want you to notice it. I labeled it equation 1, equation 2, and equation 3 to keep track. So what we're trying to do is, remember, we're trying to get it in row echelon form. So this is already a 1, all right? So that we can leave that equation. Equation 1 is going to stay the same. And what we're going to try to do, if you notice, row echelon form is going to look like this. It's going to look like 1x plus something y plus something z equals 0, and then you're going to have 1y plus something z equals 0, and then you're going to have 1z. So we need to basically get rid of the zeros in that third equation, and we need to get rid of all the x's. So this is row echelon form, again, is a stair step. Okay, so you want to get the 1s right there, and you need to get rid of the x's and y's. So you're going to use the process of elimination to solve this. And there's multiple ways to do this, guys, multiple ways. So I want you to notice the second equation, though. The second equation does not have a z. So if you wanted to, you can put plus 0z, but it doesn't have a z right there. And so we're going to solve this equation. We're going to solve it. My first step, what I would do is I would add equation 1 and equation 2 together. So I'm literally taking equation 1 and equation 2. I'm not going to write plus zeros. There is no z right there. Just going to skip space. Now, when I add those together, notice the x's eliminate. And so I have 1y plus 3z equals 5. Now, notice that right there, I'm going to call it equation 4. Because now that's a new equation that I've created by adding equation 1 and equation 2 together. And so I combine that together. Now that is right there is equation 4. So if I rewrote it now, you don't have to do this, but if I rewrote it, what do I have right now? I have equation 1, equation 4, notice I'm trying to get row echelon form. 1, 1, and now I just need to get a 1z. That's really what I need to do. So I'm getting it closer to row echelon form. So again, you don't have to do it this way, but this is the way that I would first see this problem. The x's cross out, so it's a nice, easy problem. Now, what I would do next is we need to somehow do this process again and get rid of the x's, because remember we need to get a third equation where we need to get rid of the x's, we need to get rid of the y's, and we need to find and just plain z. So I'm going to first get rid of the x's. So I'm going to take equation 1 again. So let's start with equation 1. So 1x minus 2y plus 3z equals 9. I'm going to take equation 3. So 2x minus 5y plus 5z equals 7. Now, I'm going to get rid of the x's. That's what I'm trying to do, is get rid of the x's. So I'm going to multiply this whole thing by -2. So this becomes negative 2x plus 4y minus 6z equals negative 18. And then here's my other equation. If I add these, notice the x's will cross out. I have negative 1y minus 1z. Or if you want, you can keep it that way. All right, I'm just going to, since everything has a negative involved, I'm going to just put y plus z equals 1. Now notice right there, I have another equation. I'm going to call it equation 5. And all equation 5 has are, it just has y and z. And notice equation, let me highlight it so you can see it. Equation 4 and equation 5 both have y and z. There are no x's. So now I'm going to look at just equation 4 and equation 5. So if I look at equation 4 and equation 5, and if I use elimination on this, in other words, I'm going to multiply the, I'm going to multiply this by, actually I probably should have just kept it negative because it would have been easier to do that. So anyway, so I'm back to this equation right here. So if I use elimination, the y's cross out, that's 2z equals 4, or z equals 2. So if z equals 2, let me come back up to here, now I know z equals 2. So notice I have it in row echelon form. Right there, that right there is row echelon form, right there. That's row echelon form. Now, once I get row echelon form, I know my z is 2, I just need to back substitute it in. If z equals 2, so y plus 3 times 2 equals 5, y plus 6 equals 5, which means y equals negative 1. And if y equals negative 1, I just need to back substitute that into the first equation. So x minus 2 times y plus 3 times z will give me 9, which is x plus 2 plus 6, x plus 8, which is x equals 1. So I want you to notice the process of solving. It's just using the elimination process. I strongly recommend that you label everything. Don't just do scrap work, because it's easy to make one simple mistake in the process, and then you got to go back and trace your steps. And if you're not labeling and you're not keeping track of it, not doing things in order, it's hard to find follow your steps that you've done. So try to keep track of it as you go through it. Try to eventually get to the ordered pair to be able to get to it. And then you can always check your answer by plugging x, y, and z back into the original problems to see if it equals 9, to see if it equals negative 4, to see if it equals 17. That's 9.3, solving a system of multivariable equations.